Hello, this is Mrs. Neill, and this is lesson number 8, Parallel Lines and Angles. What we're going to talk about today are angles that are formed by parallel lines and transversals. Now, we've already talked about lines being intersected by a transversal, and I've already introduced the concepts of corresponding angles, alternate interior angles, alternate exterior angles, and same-side interior angles. But what we're going to talk about today are parallel lines and a transversal. So if we have two parallel lines, right here we have R and S that are parallel to each other. How do you know they're parallel? If you will look right here, see this little darkened arrow? This little darkened arrow is a symbol telling you that these two lines are parallel to each other. And we have our transversal T, which is intersecting these two lines, which are on one plane, on the same plane. As a result, if these are parallel and the transversal intersects these two lines, you've got angles that are going to be congruent to you, or supplementary to each other. So let's just start looking at the very first one. It is corresponding angles. Corresponding angles are congruent. Now, we've talked about corresponding angles before, but now we're going to look at ones that are congruent to each other. When we talked about corresponding angles yesterday, I talked about same house, different street. So if you look, for example, this is an intersection. This is two streets intersecting each other. And here are four different houses. Okay, let's look right here at this intersection. I've got two streets intersecting each other and I've got four houses. Which two houses look the same on the two different streets? For example, if I take this intersection, if you look at angle 1, it is in the upper left-hand corner of this intersection. Okay, where is it down here? Which house is in the upper left-hand corner of this intersection? It's number 5. So if you notice, 1 and 5 are generally in the same location. But they're the same house, but they're in a different street. So 1 and 5 are corresponding angles. 3 and 7, see how 3 is in the lower left-hand corner of this intersection? Well, which house is in the lower left-hand corner of this intersection? 7. So 3 and 7 are corresponding angles. We have a pair over here. 2 and 6 are corresponding. See, they're both in the upper right hand. That's in the upper right hand of this intersection. And then 4 and 8 are also corresponding angles. So for example, if the measure of angle 1 right here is 65 degrees, what's going to be the measure of angle 5 right here? Since they're congruent to each other, it's going to be 65 degrees also. That's corresponding angles. Let's look at another pair of alternate interior angles. All right, let's look at our whole diagram right here. In my opinion, this is the outside right here of a neighborhood. These are the inside. They're in the interior of our drawing right here. So 3 and 4 and 5 and 6 are the interior. And alternate means that they're on the alternate side of the transversal. So this is my transversal. This is one side of the street. This is the other side of the street. So I'm going to look for angles that are on alternate sides of the transversal, but in the interior. So if I've got angle 3, which angle is on the alternate side, but still in the interior of the drawing? It's 6. And 3 and 6 are congruent. Okay, now there's another pair. How about 4? What's on the alternate side of the transversal, but still in the interior of the drawing? 4 and 5. So 4 and 5 are congruent because they're alternate interior angles. Okay, so let's look at just an example here. If angle 3 is 110 degrees, Can you tell me what angle 6 is? Since they're congruent, it's going to be 110 degrees also. Let's go now to alternate exterior angles. They are congruent when you have a diagram like this. Now the exterior, let's look at the exterior of our neighborhood. To me, that's going to be these right here. You're kind of on the outside of the neighborhood. And they're alternating on the transversal. So here's my transversal. So I'm looking at a house that's over here on the outside of our diagram. That's going to be congruent on the alternate side, on the other side of the transversal. So if I have angle 1 and 2 and 7 and 8, those are my exterior angles. So if I've got angle 1, which one is on the alternate side of the transversal? That would be angle 8. So 1 and 8 are congruent to each other. Okay, let's go over here. 2. Which one is on the exterior of our diagram on the alternate side of the transversal? It would be 7. So 2 and 7 are congruent to each other. So let's look at an example. If the measure of angle 2 is 123 degrees, then what's going to be the measure of angle 7? Okay, they're congruent, so it's 123 degrees also. Let's look at one more example. Same side interior angles. Now, they are not congruent to each other, they're supplementary. And remember, how much was supplementary? Two angles that are supplementary add up to how much? They add up to 180 degrees. So my two angles are not necessarily congruent to each other. They're going to be supplementary to each other. So let's look on the same side. We're looking on, that means the same side of the transversal in the interior of our neighborhood. Okay, remember we said earlier that these were the interior of our neighborhood? And I'm looking on the same side of the transversal. So where am I looking if I'm on the interior and the same side? I'm looking at angle 3 and angle 5. And they are supplementary to each other, meaning this angle plus that angle add up to 180. They're not congruent, they add up to 180. Okay, now let's look over here for some other same side interior angles on the other side of the transversal. Okay, this is the interior of my neighborhood. Here's the same side of the transversal. And which two angles are over here? Angle 4 and angle 6. Those two angles are supplementary to each other, meaning they add up to 180 degrees. So let's look at an example. Okay. If I have angle 3, that's 135 degrees, then I want to find the measure of angle 5. Well, angle 5 is not 135 degrees because angle 3 plus angle 5 is equal to 180 degrees. So, if I have one angle that's 135, I just take 180, subtract 135, and then I'm left with 45. So the measure of angle 5 is 45 degrees. Make sure they add up to 180. Okay, moving on. Remember, please remember this, that vertical angles are congruent and a linear pair are supplementary. So if I go back to my diagram, angle 1 and angle 4 are vertical angles. So are 2 and 3. That means they're congruent. They're the same measure. 5 and 8 are vertical angles. And so are 6 and 7. All right? Linear pair. They're supplementary. That means that adds up to 180. If you notice, angle 1 and angle 2 are a linear pair. There's a whole bunch of them right here. 5 and 6 form a linear pair. These two add up to 180. Let's go over here on this side right here. Angle 1 and 3 form a linear pair. See how they form a line? That means that they're a linear pair and they add up to 180 degrees. And so is 5 and 7. So there's a lot of examples right there to look at. All right, I want to finish up on the lesson today with a little exercise right here. If you notice, my diagram got a little bigger. I've got CD. Notice our markings right here for parallel. So C and D, line C and D are parallel to each other. And then if you notice, I have another set. These have a double symbol. That means these two are parallel and these two are parallel. I put a double symbol because I've got two sets of angles going two different directions, but they're parallel to each other. And notice we have 16 total angles here. So let's look at some of our examples. If angle 11 is 65 degrees, what's the measure of angle 10? What is angle 11 and 10? They're vertical angles. So they're going to be congruent, and angle 10 is going to be 65 degrees also. If angle 9 is 125 degrees, what is angle 16? Okay, let's look. I'm going to cover this up. Angle 9 and angle 16 are alternate exterior angles, and they're congruent. So angle 16 is 125 degrees also. Angle 1 is 155 degrees. What's angle 12? Okay, I'm going to cover up this part of the diagram because we don't need to look at that. So if angle 1 is 155, angle 12, they're alternate exterior angles, and they're congruent. So angle 12 is 155 degrees also. If 14, let's see, where's 14? 14 is right here. If 14 is 35 degrees, then what is angle 7? Angle 7 is right here. I'm going to cover up this part of the diagram. We don't need to look at that. So if 14 and 7, those are alternate interior angles, and they're congruent. So angle 7 is 35 also. Okay, angle 6, where is angle 6? That's 135 degrees. And then angle 10. All right, let's look at that. Angle 6 and angle 10 are on the same side of the transversal, and they're in the interior. They are same side interior angles. So they're not congruent. They're going to add up to 180 degrees. So I'm going to go 180 minus 135, and angle 10 is going to be 45 degrees. All right, last one. Angle 16 is 112. What's the measure of angle 12 right here? Okay, I'm going to cover up the top of my diagram because I don't even need to look at that to solve this problem. If this is 112 and angle 12, these are both corresponding angles. Notice they're in the same location. Same house, different street. And they're congruent. So if angle 16 is 112, then angle 12 is 112 degrees also. And that is our lesson for today. I'm Mrs. Neill. Thank you for listening.